Hi everyone, in this video I'm going to show you how to calculate building energy consumption using ClimateStudio in Grasshopper and visualizing the data. I made a general office building model in Rhino. It's a 5-story building with dimensions of 42 meters by 21 meters and height of each story is 4 meters. Now open your Grasshopper. This recipe is available for you on Canvas. You can download it and continue building your simulation from here. We're gonna get the results in 3 steps. First, defining the geometry. Second, defining the energy zones and making the energy model. And lastly, visualizing the data. Go to the params menu and drop a BREP component on Canvas and define each story of the building as their input. Then connect them to the explode BREP component. This part of the recipe is to select the surface of the exterior walls that you want to have windows. ClimateStudio tab and under Energy Setup, select Zone and Window components. Because this is an open office building, we will assume that each floor is one zone. I'll connect each BREP to zone input. And I should have mentioned that we need separate zone and window component for the first floor, and I'll explain it in a minute why I did that. So now we need to define the zone settings based on the climate region, building program, schedule, etc. Click on the setting button on the zone component and on the top corner of that window, click on the wheel. Because Charlotte is located in climate region A3, I'll filter the list by defining climate type and selecting ASHRAE 90.1 as the standard. Find and select medium open office and hit OK. As you can see, it will automatically fill out that information like people density, lighting, so on based on our selection. If you know your project specifics, you can define building exteriors and setting inputs, but because we are gonna do a general office building simulation, I'll leave them as default values. So now do the same thing for the first floor zone setting. For windows, click on setting button and select the glazing type. I choose double pane of glass. You can also see glazing attributes such as solar heat gain coefficient and U values on the top of the window. We are almost done here, but I need to specify the ground surface here since it has a different isolation than the rest of the building. That's why I needed to also separate zone and window components for the first floor. Go to Energy Setup tab and drop the boundary condition component on Canvas. Connect the floor surface to it and set it to ground. Moving on to the next step, go to the Energy Setup tab and select ClimateStudio Model Maker and run ClimateStudio Energy Model. Now I'm gonna feed what I made in the first step to the inputs of the energy modeler. As you can see, I can change the window to wall ratio value and make different energy models to run the simulations. Okay, going back to the energy model setup, connect the model to model, define a directory, and connect a button to run the simulations. I need to do one more step before running the simulations. I need to make sure the building operation system is not running all together. Let's say you want to use natural ventilation, but you don't want the windows to be open while the cold air coming in and heating system constantly running to heat up the indoor space. So I need to define running schedules based on the outdoor temperature and pedestrian thermal comfort that we learned in the previous assignment. To do that, I need two components. Construct ClimateStudio year schedule, which is under ClimateStudio library tab, and the other one is weather component, which is under climate tab. So now I'll use Grasshopper math components to define the temperature set points for each operation system schedule. Once you did that, drop a ClimateStudio library in Energy Library tab on Canvas and connect schedules to it. Now go back to the zone setting and define each system running schedule. Okay, now I can run the simulations. When running the simulation finished, you can go ahead and set those Boolean toggles to true. By changing the mode, you can change the visualization types. That concludes this video, and I'll see you in the next one.